All right, hello everyone. This is Chapter 9, Section 3, the Note-Taking Guide video lesson. This section is entitled Graph and Write Equations of Circles. So to begin with, a circle, I'm sure on the vocabulary for the test when it asks you to do, in a given example of a circle, you could just draw a circle, maybe put a center in it, maybe put a radius, something like that. But what a circle is, it is the set of all points that are equal distance from a fixed point. Okay. So it's a set of all points, I guess you could say all of the x and y's, that are equal distance from a fixed point. That fixed point is the center. So basically the center is the fixed point in which all sets are, and that makes sense. Here's a center, here's a point here. And if I started drawing all of these dotted lines and I just kept drawing dashed points, pretty soon they would all connect and you'd end up with a circle going around the center. The radius then is the distance between the center and a point on the circle. So basically what we're going to do today is you're going to be able to write an equation for a graph that has a certain center point. It has a certain radius in which all of the points on the outside from the center to the circle is all the same. It's r. And all of these points eventually make up the circle. So we're going to be writing equations for this. And they're going to come in this form. In the standard equation of a circle with a center at the origin. That's going to be an important part. The center is at the origin. The standard form of the equation of a circle with a center at 0, 0 and a radius r is x squared plus y squared equals r squared. So what's going to happen is you're going to be given examples like x squared plus y squared equals 4. Well, the radius, remember this, should look like 2 squared. And that means the radius is equal to 2. If you had something like this, basically this ends up being x squared plus y squared equals the square root of 5 squared. So the radius is the square root of 5. All you really have to do is square the 5 in order to get the radius. So, graph an equation of this circle. Identify the radius of the circle. Is this in standard form? Hopefully you're all shaking your head right now. Because for it to be in standard form, it has to be x squared plus y squared. So, add x squared to both sides. Plus, you end up with x squared plus y squared equals 16. So, the center of the circle is right here. The radius of this circle is 4. Therefore, 1, 2, 3, 4, the distance from the center will always be 4. And you should be able to easily come up with some points. And when it asks you to, you're not going to be able to use the calculator for this, but when it asks you to graph this, you should do the best job that you can at drawing a circle. So identify the radius of the circle. The radius should be 4. Now let's try this one out. Of course, it has to be in the standard form. So x squared plus y squared equals 4. Therefore, the radius is 2. All of these standard ones go through 0, 0. There is a way to make it not be 0, 0, but just worry about this for now. 0, 0, radius of 2, radius of 2, radius of 2, radius of 2. And draw the best circle you can going through all those radius, or through all of those points. All right. Hopefully that makes some sense to you. Now, writing an equation on a line is a little bit more difficult. The point -3, 4 lies on a circle whose center is the origin. Write the standard form of the equation of the circle. So for this problem here, what you have is you've got something that has a 0, 0, or center. It has a circle that goes around it, and -3, 4 -3, 4 is a point on that line. So right away you know part of the equation is x squared plus y squared. We just now have to find what the radius is. What is the distance from here to there? What is that distance? And I'm saying distance a lot because we have a distance formula in which we went where we used from a previous section. When you go back and look at chapter 9, section 1, the distance formula is equivalent to the differences squared, the sum of the differences squared. So this was a long time ago you had to do this, but this is the distance formula. And since one of the points is 0, 0, it really should not be too tough. It's just -3 squared plus 4 squared. That's the square root of 9 plus 16. That's the square root of 25. The square root of 25 is 5. So my radius is 5. So when I plug that into this equation, my equation is x squared plus y squared equals 5 squared. Please make sure when you write your final answer, you actually do that squaring. X squared plus y squared equals 25. So taking the equation and coming up with the radius and doing the graph should be a piece of cake. Coming up with the equation from a point requires you to use this formula that we have been using, or that we used in 9.1. So write an equation of a line tangent to the circle. All right. This is a new word for you right here, tangent. In your note-taking guide, it tells you that a line tangent to a circle and the radius to the point of the tangency are perpendicular. So what you're going to end up with is you're going to have a circle. You're going to have the point 4, -1. And what you're looking for is you're actually looking for this, the equation of that line. All right. So to find the equation of this line, you need to know the slope of the line and at least one point. Now we already know 4, -1 is a point on this line. All we have to do is imagine that this radius has a slope. I mean, we don't have to imagine, it actually has a slope. From 0, 0 to 4, -1. So if we use the slope formula, let's see, y2, let's just say 0 minus -1, divided by 0 minus 4, gives us a slope of -1/4. This line right here has a slope of -1/4. All we did was we used the slope equation from here to there. Now, perpendicular. We talked about perpendicular just a few class periods ago. Perpendicular lines are opposite reciprocals. So if we have negative 1/4, the opposite reciprocal should be changing the sign and flipping the slope. So what we have is we have a slope. The slope here is 4, and it goes through that point. And we have this form here. We've done some of these just previous class periods. Watch some more of the videos from chapter 9. You'll have this equation kind of explained. Y minus the y value, negative 1, equals the slope times x minus the x value. And now we go ahead and distribute. Subtract 1 from both sides, and now you have your equation. Y equals 4x minus 17. So here we incorporated many things from the whole year. The slope formula, long time ago. The point slope formula right here. Understanding perpendicular lines, and we related it to circles. All right, here is a story problem about a lighthouse. The beam from Oak Island Lighthouse in North Carolina can be seen for up to 24 miles. You are 18 miles east and 9 miles south of the lighthouse. Can you see the lighthouse beam? All right, so let's imagine here's the lighthouse. It's the center. And all the way around this lighthouse is 24. The radius is 24. So what you're looking at doing here is you're trying to figure out, is 9 9/18. There you go. Is 9/18 within this circle? So you're on a boat somewhere, and your boat might be here, it might be here, it might be right on that line. The question is, can you see the lighthouse beam? All right, there's a few ways you could go about doing this. What you could do is say, we know that east and west is left and right, so that's x and y. Up and down, north and south, so we're looking at 18, 9. Here's your x, here's your y. This is your east, that is your south. So we could just use the distance formula to see if the distance from the origin to here is less than 24 miles. So let's start off with that one. The formula for distance: the difference of the x's squared plus the difference of the y's squared. And since the origin is one of them, really all you have is 18 squared plus 9 squared equals, when you work this out using your calculator, you type it all in there exactly the way it is. 18 squared plus 9 squared. Make sure that's the square root of 405. And when you square root that, you see that it is basically 20 miles. So 20 miles. Is that within? Can they see it? You would say yes. because you can see the thing from 24 miles away. You're at 20 miles, so you absolutely can see it. The other way is simply to use the equation, x squared plus y squared equals 24 squared. We know the radius is 24, so let's plug in this x and this y. 18 squared plus 9 squared equals 24 squared. And as long as this number here, which is 405, if this number here is less than this, which is 576, you still get a yes. Either way, method here should give you a yes answer for this. All right, here is I believe, a checkpoint. Write the standard form of equation of a circle with a center at the origin that passes through this point. We know for a circle it's x squared plus y squared. If you get anything else, it's not a circle. If this is a minus sign here, it's not a circle. It goes through the origin and that point. So unfortunately, we can't just come up with the radius right away. We have to use the distance formula. I'm not going to write it out again because I've already done it twice or 2 or 3 times. So it's 6 minus 0 squared plus negative 3 minus 0 squared. That ends up being 6 squared plus negative 3 squared. That's 36 plus 9. It's the square root of 45. So the radius is the square root of 45. So when I put that number in there, the square root of 45, you have to remember that the radius is being squared. So my actual answer for this, the equation, is just 45. Please don't, that's going to be a common mistake that you come up with. It's the square root. You square the radius, so if the radius is a square root, it's just the number. Write an equation of the line tangent to the circle. All right, look, we have the equation. We actually know what the radius is, and we're looking for it right here. Okay, the radius actually is not important for this. What we're looking for now is the slope of the given radius. That means m of that radius is 0 minus negative 5 over 0 minus negative 3. So my slope minus a minus minus a minus ends up being 5/3. This is the slope of the radius. Please remember, tangent lines are perpendicular. That means opposite reciprocals. So my new slope is not 5/3, it's the opposite of this. So it's negative, and it's the flip, the reciprocal. So it's negative 3/5. All right, now that we know a point and the slope, we use the point slope formula to come up with the equation. Our 1y value is a negative 5. Our slope is negative 3/5. X minus negative 3. So let's fix some of these negatives. Minus a minus, minus a minus. So you got y plus 5 equals 3/5. Oh, that's negative here, right? Negative 3/5 x minus 9/5. And after you do a little bit of work here, change 5. Let's make this, we have to convert this to a fraction. Actually, you can do this a couple ways. You can go straight to decimals if you want, or you can do fractions if you want as well. 5 as a fraction would be 25/5. And when I subtract 25/5 from both sides, you get negative 3/5 x minus 34/5. So, you can have this as decimals if you want. You can whatever makes you feel better. All right, this is the last checkpoint before your homework. Suppose you are 16 miles east and 19 miles south of a lighthouse. Can you see the lighthouse beam? Oh, this is from example 4. So you have to remember that we can see it if we're 24 miles out. Or within 24 miles. Was it 24? Yep, 24. So, let's choose the two different ways. Distance formula is the square root of 0 minus 16 squared plus 0 minus 19 squared. It's the square root of, all right, you go ahead and type that into your calculator. Make sure you put parentheses around the negative before you square it, otherwise it's going to be all messed up. So now it's 617, which is approximately 24.8. So, are we within the 24 miles? You would say no. If you use this equation, you would put in the x and the y. You would do 16 squared plus 19 squared equals 24 squared. And when you type that in, this part right here ends up being 617. And this number over here is 576. We should be not equal to, well, we could be equal to, but this number should be less than that. Is it? So no. So that's how you go ahead and set up these circle problems. This should be your assignment for 9.3, 1 through 57 odd, 63, 65, and so on. Please go ahead and try these out. Try some of the practice problems out. We'll do some in class, and we'll go from there. Good luck.